We've already talked about like terms and terms that are not like terms. Say, for example, when we found the perimeter of a figure that looks something like this, and we had the straight parts here, and then we had the distance around the half circle, and we got this answer in inches, and we said those are not like terms, are they? Can't add them together. We can't say it's 28 times pi. It's not the same thing, is it? We saw some others when we were finding the surface area of a circular cylinder, and you guys used the formula. I think you came up with an answer like 60 pi plus 18 pi, and we said those two are like terms, aren't they? They're both times pi. So 60 times pi plus 18 times pi is 78 times pi. So we can put those two together. This would be in square inches, and that would be the surface area. So what's the difference? Why are some like terms and why are some not? Now let's just take a look at this. We talked about this yesterday. Are those two like terms? 5 times 3 plus 4 times 3. They are like. It is 9 times 3. Okay, so 15 plus 12 does equal 27, doesn't it? They are like terms. They do work out. And then we said, well, what if I had 5 times x plus 4 times x? Okay, we don't know what number this is, do we? We don't. X is a number. Let's get that clear. Okay, it's a number. Don't look at x like it's a variable or a letter. No letters. They're numbers. Okay, they're numbers. So we don't know what it is, but we do know this, and this is important, everybody. The x, this number right here, and this number right here, they're the same number. They could both be 3s, they could both be 5s, they could both be 1/2s, they could both be -10s, but whatever they are the same number. And that's important. They have to be the same number in the same problem. That makes sense to everybody? So if that's the case, 5 times this number plus 4 times the same number is 9 times that number. We can add them together. So what makes them be like terms? You look at the numerical coefficients, are they the same?
Yes.
Wait, the numerical coefficients, are they the same?
No.
Are the literal coefficients the same?
Yes.
Yes, they are. So when the literal coefficients are the same, they're like terms, and you can add them together. And I want you to notice something very important. Look at the answer. Do you notice that the answer is still a like term? Okay, if you combine like terms and your answer, Matt, and when your answer is not still a like term, you didn't do it right. Okay? You need to really think about that. So, let's see here. 4xmp plus 6pmx subtract 10 xmp. Are these like terms or not? Or some of them and some of them not? What's the deal? They're all like terms, aren't they? Now it's hard to tell, isn't it? These two are a little easier. Why are they a little easier? Yeah, they're in the same order. This one's out of order, or it's in a different order, I suppose. So it's a little tougher to look at it and say, yeah, that's a like term. But these are like terms, aren't they? And what do they add up to then? 4 plus 6 subtract 10? 0. 0 xmp or pmx or mp, whatever you want to say. But what's 0 times anything, guys?
0.
It's just 0. Sometimes I get this answer from you guys. You'll put these 3 numbers together and you'll say, oh, it's this is the answer. But if I write this, what's the numerical coefficient? 1. Right? So if the numerical coefficient is 0, then that term's gone, isn't it? 0 times anything, 0. My daughter showed me this stupid video the other day. It was this, supposedly this really super smart guy, and he was doing a calculation, and it went across the chalkboard. They had one of these chalkboards that went around the room basically, and he's going down, just counting super fast, and it had 35 plus 27, subtract 143, and it was just, I don't know how many there were. There must have been 100 different sums to do. And he was just walking down, looking at them, boom, 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 boom. And I noticed at the very first there was a parenthesis before the first one. And I wondered why that was there, but anyway, we're going along, you're going along, and you're watching the guy, and it only takes like 10 seconds. And then all of a sudden, you're like, wow, he can add those up fast. And then they get to the end. What's the answer? Yeah, he was brilliant, wasn't he? Anyway, I was like, well, that's 10 seconds of my life I'll never get back. And it took longer to tell you guys the story, but anyway. So here's your job. Ready? You're going to be given an expression. Now, this is not an equation. There are not two sides. There's no equal side connecting them or any equal sign connecting them. This is just an expression. It's like half of a sentence. Let's think about English class for a minute. If I just say, holy crap, is that a complete sentence?
Yeah.
Or is that just an expression? Yeah, it's just like part. Now if I say, holy crap, Mason, that buck you shot this year is huge. Right? That's a complete sentence. Equations are the same way. They have to be a complete sentence in order to be an equation. This is not a complete sentence. Now if I got done here and I said is or equals something, then it would be an equation. So right now we're just working with one side of the equation. We're just looking at an expression. And your job is to simplify it by adding the like terms. Now yesterday we learned step 1 of solving an equation. You remember what it was? Yep, get rid of the parentheses by using what? The distributive property. Today we're learning to simplify by adding the like terms or combining the like terms. Look at the second step for solving an equation. You guys are learning to solve an equation. Okay? So this is the second step. Now we're not putting the steps together yet or anything. We're just doing them separately. But once you get good at them, you're going to have it. Hey Taj, you awake? All right, just checking. All right. So here we go. Now you don't have to do this in any particular order, but I usually just start with the first term and look on down and say, are any of these other terms like terms? Hey, look at that one. Like terms, right? Let's put them together.
Negative 2x.
Negative 2x. Now remember, hey, see this plus sign? What's it for? The 5. Does it have anything to do with anything after that?
Nope.
See that negative right there? What's it for?
XY.
Yeah, the negative 1 xy, right? Okay. So let's just be clear about that. So anyway, that took care of those two. And then that was it. So I go down to the next one. Plus 5. Anything a like term with it? No other constants? Okay. So we're just going to say plus 5. That takes care of that one. And then I go down to the next one. Negative 1 xy plus 2 xy. Are they like terms? They absolutely are. So we can put them together. Negative 1 and 2 gives us positive 1. So plus 1 xy. Do you have to put the 1 there? No. I'm going to for a while, but normally I'm too lazy. I would just write xy. So that's your job. Simplify it by combining the like terms. Look how much simpler it is. It's way better, isn't it? Yeah, that's it. That's your job. Okay, so, oh wait, what if someone else has this answer? Is that correct or not?
Yes.
Yeah, see your head shaking? Yeah. It doesn't matter what order it's in. As long as you have a positive 5 and a negative 2x and a positive 1xy, it doesn't matter what order they're in, they're going to add up to the same thing. So that's nice, isn't it? Okay, here, let's take a look at another one. In fact, why don't you guys just do this one? I think you can do it. Just simplify it by combining the like terms. Do not write down the original equation, guys.
What?
You can make it look much better, Gage. Yeah.
So if I want, so I can move this around any way I want to.
Mm-hmm.
I don't have to like +1 start to another.
No, you don't want to do it. Remember, addition is commutative, and even if it says subtract, we're adding a -1. So because we're adding, we can do it in any order that we like. So I can look at the first term, 3x, and say, well, I think I can put this -1x and this -3x. Can't we put all three of those together? Well, this is kind of cool. What do a 3x and a -3x give you?
0.
Yeah, those add up to 0. So really all we have is the -1x and right there. So that takes care of all those, doesn't it? They all add up to -1x. Then I just keep going down. Okay, I got a -1x, and I've got a -2x, and I've got, oh, sorry, y. -1y, -2y, and -8y. Those are all like terms, aren't they? So we can put those together. -8 and -2, so -11 times y, that's right. So all three of those add up to -11y. And then what about the 5 and the -10, the constants? Yeah, that's just -5. So have we simplified it by combining the like terms?
Yeah.
Yeah. Sometimes we get confused because I say add like terms, and you guys will see something like here, 4a subtract 5a, and the instructions are add like terms. And you're like, well, I can't add because it's subtract, right? But we have to keep in mind that what we're really doing is this. We're adding, okay, we're always adding. So we're adding a -5a. So when we say add like terms, you can make it happen. Okay, ready to do another one? Too bad. Here you go. -2xy plus 3x plus 4 subtract 4yx subtract 2x. Combine like terms. Simplify by combining the like terms. Hey, nose.
Oh.
That's better, Thomas. You got it? What do you think? Are these like terms? Now one's xy and the other one's yx. Whose mom's calling them?
That's mine.
Yeah. So even though this one's x times y and this one's y times x, that's okay? All right. And so -2 and -4? -6. xy? Okay. Gage, get your foot down, turn around, pay attention. So that takes care of those two. Now, what about the 3x and the -2x? Positive 1x. And then plus 4. Who did that right? Okay. Here, let's do another one. You're all going to be experts. Okay, there's only one constant, the 4, right? So it's just by its lonesome. But I think these two are like terms. Do you guys think?
Yes.
So we have a negative what? Negative 1 and a positive 3. That's positive 2x, isn't it? So that takes care of those two. Then what about these? Are they like terms or not?
Yes.
Wouldn't it be nice if they were both written xy so that you recognize that they were like terms a little bit easier? And that's why normally I will put things in alphabetical order. And as we get into more complicated problems, it's a good idea when you write it down to put it in alphabetical order, or at least everything in the same order, so that when you look at different terms, if they're like terms, you recognize that a lot easier. Okay? So we have negative 2 and negative 7. That's negative 9xy. Anybody have this in a different order? Okay? So which one do you have first?
I have the 2.
This one? Is it positive 2x? Okay. Then what?
Plus 4.
Then the plus 4. So you have a positive 4, and then you have a negative 9xy. Doesn't matter what order we have it in, as long as the 9xy is negative, the 4 is positive, and the 2x is positive, it's fine. That's something we've really got to remember. They all mean the same thing. Let me show you. Is 4 subtract 3 the same as 3 subtract 4? No. Is 4 subtract 3 the same as negative 3 plus 4? Okay. So as long as we keep it addition, as long as we think of we're putting a 4 and a negative 3 together, we're combining them together, as long as we're adding, we can do it in any order that we like. And that's why this works. I don't know what else to tell you. They're easy. You can do them in your head almost as fast as you can write them. The assignments are going to take you less time now. You're going to have plenty of time today in class to get it done and not have anything to worry about this weekend. Let's go.
Oh yeah, today's Friday.
Yep, and we're going to hand this in. We're handing this assignment in at the end of class. So let's get it done.